In this video, I'm going to go over the 5.3 problems 29 to 32 found on page 187 in your textbook. So number 29, they want to know which of the following processes are endothermic. And number one is H2O solid going to H2O gas. So that's definitely going to be endothermic because you have to put energy in to change something from a solid to a gas. And then number two, CO2 gas to a solid. If solid to a gas is endothermic, gas to a solid has to be exothermic since it's the reverse process. And that makes sense. You have to slow down and pull the particles closer and get rid of that excess energy. And then the question is whether or not number three is also endothermic or if it's another exothermic. So both reactant and product are gases, O2 and 2O. But what you have to realize is that this is bond breaking going on for O2 to form two free oxygen atoms. And bond breaking is always endothermic. So both 1 and 3, which would correspond to letter B. Number 30 asks, identify the equation which represents the bond enthalpy for the HCl bond. Bond enthalpy is bond breaking, and it has to be in a gaseous form. So as we look at A, B, C, and D, they all start with HCl as the lone reactant, but D right away we can eliminate because it's got HCl in an aqueous form. So that's not going to represent bond enthalpy. So A, B, and C all have the correct reactant. So the question is whether or not new bonds form or other energy is consumed on the product side. And in letter A, the HCl bond is broken and forming gaseous H and gaseous Cl by themselves, just monoatomic atoms, requires no energy. So A appears to be our correct answer. If we look at the other two, B, HCl, the bond is broken, but we form two new bonds when we form H2 and Cl2. Even though it's only half the value, it's still a bond to form H2 and Cl2. So we'd have to subtract those bond enthalpies. Remember, it's reactants minus products. So we would not have the net value for HCl on B. And C, even though no new bonds are formed, to form an H plus and a Cl minus ion, that's going to require ionization energy to remove the electron from the hydrogen atom and move it to the Cl minus. So again, the HCl bond is going to be, the energy is going to be affected by this ionization of the hydrogen ion. So the only one that represents just the HCl bond enthalpy is letter A. Number 31 is very similar to number 29. I'm kind of surprised they had them so close together, but they want to know which of the following processes are endothermic. So 31, CO2 gas to solid, you're going to have to lose energy for that, so that would be exothermic. H2O solid to H2O gas, that would require energy or be endothermic. And going from O2 to O atoms, that would involve bond breaking or would also be endothermic. So in this case, it's going to be 2 and 3 that are endothermic, and that would correspond with letter C. Number 32 wants you to identify what bonds are broken in the following process. So you notice you start with C2H6 and you end up with 2 carbon atoms and 6 hydrogen atoms. So there's no bonds in our resulting products. So really the question is, what does C2H6 look like? Well, if we put the 2 carbons in the center and attach the 6 hydrogen, we notice we have what's called a saturated hydrocarbon. That means there's all single bonds. And so what's going to be broken is 1 carbon-carbon single bond, don't forget about that, and then 6 CH bonds. So a total of 7 bonds are going to be broken in number 32.